People have been asking me a question on how to populate such a question on Risa. So the question is basically asking the moment at all the supports, and you're gonna have moment A B, then moment B A, moment B C, and moment C B. So as you can see, it says there's a settling at 0.1 inches. I mean 0.8 inches at support B, and this has been giving most people a hard time. So as we can see, it says beam AB has a moment of inertia of 890 inches cubed. And that we have to know exactly what steel is that, and as well as for the beam BC. So here, when you open up Risa, this is how the layout is going to look like. The first thing you want to do, you want to go to global and enter your information. This will give the instructor or teacher or whoever is going to check this work know exactly who was working on it and what job number it was. So you're going to enter information like and whatever information. So I'm just going to put as an example, I'm going to put Mambo as my company and my job number one. And you can put who the designer is, like that's your name, who is designing this. Then you're going to click down at apply, then okay. Then the second thing you want to look in is the units. So when you look back to the question, it says we're using empirical coordinates. So I'm gonna go back to my Risa and go to units and change it to empirical, standard empirical. And I'm gonna click OK. Then the last thing is you wanna see, because this is Risa 3D, but we're working on two dimensions. So when you look at the question, it's 24 feet, then 8 feet, and 8 feet, which is a total of 40 feet. You can divide this on your to make your coordinates so that you have a very clear picture of what you're doing. So to do that, I'm gonna go to edit coordinates, then I'm gonna click on that. Then when you look at your drawing grids, it says 30 at 1 foot. That means you have on your x direction you have 30 of these boxes in the x direction, and each box represents 1 foot. So what we want to do is we want to represent 8 feet each, and we're gonna make them 5, so to make a total of 40. And on the y, we really don't have anything going on the y. When you look at back to the question, we don't have anything going on the y direction except for 0.8 inches, which is your deflection, your settling. So what I'm gonna do is I'm gonna say, because that 0.1 inches is very way lower than 1 foot, so I'm just gonna put one box and plug it in 1 foot. Then I'm gonna click OK. So as you can take a look, this is how our drawing grid looks like. So what we're gonna do is we're gonna go and draw a new member. That's the very first thing you're gonna do. When I click on that, and it populates a drawing member. So when you look back at the question, it says we know this is a steel beam, and it's at AB we have 890 inches cubed, and that will be a W18 by 55 and a grade A36. So I'm gonna go to my start shape, and I'm gonna look for 18. It's gonna be all the way on the top. So 1855, there we go. And so this is one thing you don't want you don't want to do. You do not want to mess up with your Risa library. I'm gonna click here just to show you that it's 890 inch cube, the moment of inertia. So when you go here, it says 890 inches cube. You do not want to change anything here. So I'm gonna close it so I don't mess up with it. Then I'm gonna click OK. Then I'm gonna change my material grade to A36. That's what we're gonna work on. Then I'm gonna click apply. Then back to the question, it says the 890 inches cube moves from A to B. That's my beam AB. That's what I'm gonna do right now. So I'm gonna click my starting point. and so these are 8 feet. 8 feet is 8 feet inch, 8 feet each. So so 8 times 3 is 24. So to make it to 24 feet, I'm gonna do 3 inches. I mean three coordinates. I'm gonna move three boxes. So there you go. And that's my first. Then I'm gonna click escape to get rid of that. Then I'm gonna go back to it, click on it. Then our second beam is 1170 inches cubed. So I'm gonna click on it, and that will be my it will be beam 20 W2175. So I'm going to 21.7. I'm gonna look for 21.75. 21.57, sorry. 21.57. And when I go to edit, it will show you here 111.71. 1170. Then okay. Now I'm gonna click OK. You don't wanna mess up. Oh, so changes, it says save them to the database, and you say no. You do not want to mess up with your changes. And grade A36. Okay. I'm gonna click apply. And that's gonna be my rest of my beam. Then escape. So back to the question again. It says we have a fixed support on A and C. So to do the supports, we go here on supports, then you change it to fixed. Now, since we're working on two dimensions, we are only dealing with the y, and this is our the global axis. We're gonna deal with the y and the x, and the moment is gonna be through the z. So I'm gonna change all my reactions. I'm gonna put them fixed on all, and leave the rotation, which is the moment, at z. Then the reaction at x, the reaction at y. Now I'm gonna click apply, then put my coordinates on the two nodes. Then the next thing is we have a roller at B. So I'm gonna go to my supports, then click on roller, then do the same thing again, keep them fixed. And there you go, you click apply. You only have, a roller has only a y direction, so a reaction in the y. So apply, then I'm apply a roller there. So now we already created the beam and the supports. The rest is the applying the loads and the deflection. So to apply the distributed load, we're gonna go over to our distributed load, that load. Then the magnitude is 2 kips, so I'm gonna keep the 2, and that's from the starting and the end. And the location for the first beam is 0 to 24, so 0 to 24 feet. Then apply. Click right up. So for some, this load might not show up. This is due to your toggle display of load. So when you click this, it shows that the load disappears. While actually, when you go to your basic load case, you're gonna see your distributed load right over there. So the load is still there, but since this is turned off, then you won't see the distributed load or any other load that's acting on the beam. So click on that just to show that you're in basic load case 1, and you're showing all the loads that are in basic load case 1. Then so the next load we have a point load of 30 kips, just right in between of BC. So what I'm going to do is I'm gonna click on my point load, and so it's at 8 feet, and my beam is actually 16 feet. So if I say 50%, this will take me to 50% of the beam. And the magnitude was 30, so I'm gonna keep it there as -30, and that's the y direction. I'm gonna click apply, and When I click